Okay, so we need to talk about how you take something that looks like this and turn it into something that looks like that. So if you have a polynomial divided by a polynomial and the bottom's factored, well, what you're going to do is this. If you got this guy, you're going to guess and just hope and pray that you can take this fraction and rewrite it as a over x plus 1 plus b over x minus 3 for some numbers a and b. So you're just going to take a wild guess. You're going to take this fraction and say, you know what, I really, really hope I can find numbers a and b that make this true. Now it turns out somebody proved way back when that this is always going to work. This is called a partial fraction decomposition. It turns out you can always break a fraction up into its partial fractions. So, but the theory isn't so important. Once we, when we try this, we'll find numbers a and b, and we can actually just verify that they work. So it turns out we're not getting lucky. This will always work. So we're going to take this guy, hope we can rewrite it as a number over x plus 1 plus a number over x minus 3. Okay, so now we got to try to figure out what a and b are. So I want to solve this equation. I have an equation involving a fraction here. Well, if you want to get rid of fractions in an equation, you can always do it. All you got to do is look at all the denominators of your fractions, and you just got to multiply by all the different pieces you see in the denominators. So you look at all your fractions. I see an x plus 1, and I see an x minus 3. Repeat it over here. So I'm just going to multiply both sides of the equation by an x plus 1 and an x minus 3. So when I multiply on the right side, I got to distribute x plus 1 times x minus 3. All right. So the whole point of doing that, remember, was to get rid of fractions. So this trick will always work. X plus 1 crosses off with that x plus 1. X minus 3 crosses off with that x minus 3. X plus 1 crosses off with this x plus 1. X minus 3 here crosses off with this x minus 3. So now I have 5x minus 3 equals x minus 3 times a plus x plus 1 times b. So I got to find numbers a and b that make this equation true. All right, well, there's a trick to doing this. So I'm going to distribute. I'm going to multiply out that a. So I'm going to have ax minus 3a. And I'm going to distribute the b. So I have bx plus b. Now what I'm going to do is I'm going to collect the stuff with x's in it. So I'm going to put the ax and bx, I'm going to put those together, and I'm going to put the other numbers together. So I got ax plus bx, and then I have negative 3a plus b. All right. Now what I'm going to do is I'm actually going to factor out x here, so that I have a plus b times x. And then I've got these numbers here. I'm just going to group those together. I can put parentheses around them if I want. So the trick is this. Look at what we have on the left and right side of the equation. On the left side of the equation, we have a line. On the right side of the equation, we have a line. A and b, remember, just stand for numbers. So on the right side of the equation, we have a line. Here's its slope. Here's its y-intercept. So we have this line equaling that line. The only way that's possible is if this number equals this number, and this number equals that number. We got to have that the slopes are the same. 5 has to equal a plus b. So 5 has to equal a plus b. Slope's got to be the same. And the y-intercept has to be the same. Negative 3 has to equal this number here. So it allows us to set up two equations. A plus b has to equal 5, and negative 3a plus b has to equal negative 3. So all we got to do now is solve this system of equations. So there's a lot of ways to do that. One way is the elimination method. So let's see. Maybe I want to, what do I want to do first? Maybe I want to get rid of that b. I'm going to take this equation, I'm going to subtract this equation from it. So a minus negative 3a gives me positive 4a. b minus b gives me 0. 5 minus negative 3 gives me 8. So I end up with 4a plus 0 gives me 8. So again, I did this equation minus this equation. 4a equals 8. That must mean a equals 2. Aha! Well, if a equals 2, then I'm going to take 2 and plug it in up here. I'll say, okay, well that means 2 plus b equals 5. So b equals 3. All right, yay, I found numbers a and b. So what's going on here is this. If we have 5x minus 3 over x plus 1 times x minus 3, it turns out we can rewrite this whole thing as 2 over x plus 1 plus 3 over x minus 3. So that's how I got from this step to this step in the last problem. It's a lot of algebra, kind of a pain, but look how much easier it made finding the antiderivatives.